Okay, guys, welcome back. So, if you remember the last time, I figured out that this guy was too thick to use with just the normal risers. So, I 3D printed some extensions, which meant I had to go out and buy longer bolts or screws, brass screws. So now I can put the extensions on each corner and get this guy going. What I want to do though is I don't like this temporary holder I have here for the opposing magnet. So what I want to do is measure this off and then get another plate and actually put some sliders in here at different heights so I could slide a piece in there with it on there, because otherwise I have to see I have to hot glue this down, which I don't want to do because that makes it a real pain in the ass. So yeah, let me get that going. And also too, I've gotten some ideas from commenters. I forget the guy's channel, Toffee Flavor, and of course Magnus Attractus, talk about the magnets. So right now I have north south facing outward, and they were talking about what's called, I guess, a buck configuration, where they would face inward. So north south, south north, north south, south north, facing inwards. And apparently that makes for a higher, excuse me, or a denser magnetic field, which should still produce a north south, north south. So because I have this temporarily put, or because I've used no glue, it's all just pressure fit, it shouldn't be hard to make that change. Of course, I'm going to first try it out the traditional way I always do, with north south facing out. This thing is really nice. It's heavy and it flows really freely. Right now it's not being repulsed by the magnet. It's just being held on by the tightness of the bearing, which is no good. I want it to be able to slide up and down freely. But I think that's because I have this cocked and the whole 9 yards. If I were to shake that around, it would push down a little bit. Anyway, let me get it apart, make sure that it does float up and down inside the bearing so that it'll actually work with the repulsion. Take some measurements, figure out how I'm going to do the slide, and I will be back. Stay tuned. All right, guys, welcome back. So continuing on the build, I decided to 3D print, because this is 3D printed pulse motors, right? I decided to print out a bottom tray for the repulsive magnet that's going to sit right underneath this guy here. And I'm actually printing out some smaller extensions, and I'm using this clear PLA because I have a ton of it. I think I have some kind of weird thought about clear PLA, that it's not as strong as regular PLA, when in fact it is. It's just clear. And so here's the clear riser I was talking about, because I don't think I need that full height, but we'll see. Anyway, what I really wanted to talk to you about was this 10-pole rotor, and possibly turning it into a 5 super pole rotor. And it's funny because G-Law, now Magnus Attractus, told me about this a while back, but I got re-intrigued by it when Toffee Flavor talked about it. So right now I have the poles facing out, right? North, south, north, south. And if you look the way this rotor is set up, so it's 10 poles. If you look the way it's set up, these two inner sides are kind of facing, oops, what happened there? Oh, anyway, they're kind of facing outward. So if I were to set these up, I guess it's called a buck configuration, where I have both of the, so I have a north pole inward here and a north pole inward there, I would get a super north out here. Same thing with south north. So that would drop this down to 5 poles, but they would be super poles, I think. And so I'm really eager to try that. The first run is just going to be normal, or normally the way that I do it, with just north south facing outward and inward. Excuse me. But because of the way I built this, it's easy for me to turn these. So I would turn 2 norths here, 2 souths here, 2 norths here, 2 souths here, all the way around, which would give me only 5 poles. But again, based on, I guess, the information I received, they would be super poles. And because they're already kind of facing outward, the magnetic flux would show up right here as a super pole in between the magnets. But that means I'd have to turn each of these like this, which is, again, not a big deal. But I've got some more stuff printing. I'm hoping to get this puppy done today and get a first run going. But I'm really intrigued about that new positioning of the magnet, because I've always positioned mine like this for normal pulse motor operations. But now that I think about it more, this would make more sense doing it with the 2 like poles facing inward, and they're actually not even fully facing inward. They're kind of on a slant. And I was even looking about reprinting these top and bottom plates where these are twisted a little bit more. But if I do that, I will lose a pole. So instead of 5 super poles, I'd only end up with like 3.5, which is not going to be any good. So I'd rather stick with the way this is laid out now. So I'd have a super pole 1, 2, 3, 4, 5. Oh, wait a minute. 1. Oh, actually, I'd still have 10 poles. What am I talking about? Why did I think I would only have 5? No, wait, I would just have 1, 2, 3, 4, 5, 6, 7, 8. No, I would still have 10. Why did I think I was only going to have 5? Anyway, I'm not going to delete this. Show you the way my brain works, which is, a little crazy, but excuse me. Anyway, I finished this thing. Now I just need to wait. You know what? I may put this together now and not wait for the clear. Oh, that's what fell. One of the other risers, the clear one. What happened to it? Dagnabbit. Man, if something hits the floor here in this shop, it's gone forever. It's like mystery meat down here. It takes off underneath the workbench or underneath the table saw, and it's gone. Anyway, stay tuned. Just to give you a quick little sample of how it looks. I've got it floating maybe about 1 inch, 1/2 inch, 3/4. Works really good. What I'm going to have to do, though, is put a shim in here, because it's very easy for this to get pushed away. But again, no big deal. I can actually put a stopper back here so that it can't go that way, and then just put a little shim there. Anyway, stay tuned. My video kicked out, so I think you can see them. They're right there, little stopper right there, and then one right there. And it's perfecto. and it won't kick out this way. I don't know why. I've tried to coax it out and it won't, but I will put a temporary, or I'll put a little shim in there so it just can't. All right, let's get this bad boy together. Stay tuned. So yeah, that's how it would eventually look, of course, with the screws down in here. And I even printed out some clear washers. But I think I'm going to try the smaller spacers first. But yeah, that puppy is beautiful. I can't wait to try that new pole configuration though. All right, let me see what's going on in the printer. Stay tuned. Welcome back. So I've got two of those smaller spacers printed out. And that's the kind of gap we have there, which isn't really enough. I mean, I can push down to see if that'll... Now it pushes it back up, which is good. That's what I wanted to do. I think it's plenty there, but just in case, I think I should either add a washer underneath there or just go with the red ones. The red ones give me plenty of space, but I love to tinker around with this stuff, so we'll see. Stay tuned. Welcome back. So I've got it all together. Now all I have to do is just fire it up. But I was thinking there's got to be something I can do with this extra rod here. I bet you I can build another rotor off of that, maybe a smaller one, or even one the same size as this, for some extra added pickup action. This thing is so nice, it spins forever. This tray is working a lot better because now I can move the whole thing and I don't have to worry about it. It's all self-contained. It looks like it has a wobble, but that's the outer skin, I think. I think because it's not exactly centered. So I think if I... Yeah, that's the outer skin. So I have to... See, that's got to come down there. Got to go up there. Got to go up there. Anyway, that's the solid skin. It's no big deal. It looks like it has a wobble, but it doesn't. Well, actually, it does have a little wobble, but that's all right. I've not balanced anything yet or done anything like that, but I'm probably not going to worry about it. When I do fire it up, though, I will stand clear of them flying magnets. Stay tuned. Welcome back really quick. So the whole reason why I started recording now is to talk about this extra real estate up here. What do you guys think I should do with it? Should I build another rotor to go on there? Maybe I could even put the beast rotor up on top of there. But I'd have no way of... Well, yeah, and I could put a magnet down here and then one on the base of the other thing so I can get that repulsion action. We'll see. Stay tuned. Welcome back. Time to talk about some goof ups. Well, it's not really a goof up. So I built this tray. You see the supports down here. This tray was built with that big guy in mind, the beast rotor. Therefore, its positioning for the coil is way too far away for this one. So I'm going to have to build another tray. Thank God I do have another one that I could modify for this setup. Yeah. Welcome back. So I wanted to show something to you guys. Talk about committing to nothing but 3D printing. These nuts right here, they're 3D printed. And they work absolutely beautiful. As well as this 3D printed threaded rod. And I did that guy out of that copper infused PLA simply because I had a ton of it. Now, I didn't think I was going to get any benefit from the copper because in doing some more research, it turns out that there's really not a lot of copper in that particular vendor's copper infused PLA. The iron PLA, on the other hand, was from a different vendor, and that had a ton of iron in it, and the proof was in the fact that a magnet stuck to it. So it had enough anyway to become ferrous. These guys, they're just basically plastic, but still, they're really cool. I mean, look at that guy. I love 3D printing. Anyway, I think I'm going to set it up like this with one of the Sky rotors, Sky coil, and give it a first run. Stay tuned. Welcome back. So I've got it set up and it should work really well, but I hate this temporary stuff, these clamps. I want to do something so there's no clamps. You know what I mean? When I engineer something or when I design something or build something, I want it to be like nice, elegant, not, no clamps. No clamps, man. This is nice and stiff. This guy's floating nice. I think these guys may be too small. I printed these at half the height, like about 15 millimeters. And I think they may be too small. But I'm going to keep them anyway. Because you never know. You never know. So let me now I got to figure out something. Before I do a first run, I got to figure out something for this. So next time I come back, it'll be a first run with a modified setup. Stay tuned. There we go. Nothing but a couple of little black screws will fix. All right, let me hook up the JL94 circuit and get this puppy going for a first run. And then I'm going to immediately change out those the magnets, I think. Oh, I'm definitely going to do it. I don't know if I'm going to do it now. All right, stay tuned. There it goes. It's got a nice sound to it. And you can see it's putting out a lot of back EMF through this beautiful circuit. God, that is nice. So yeah, I want to put a coil here, and see what I can get off it. I'm wondering how much it's putting out here. Let me set this down and take a quick reading. Oh, I'm gonna have to put you guys on pause. Hold on. Sorry about that. I can't find my stand. So it's putting out 10 volts coming to this little light here. But yeah, it's nice. This platform's got a little bit of vibration to it. But it is nice. Everything's holding together really nice. It's doing its little balancing act there on top of the magnet. I have those beautiful ceramic bearings. Yeah, let's see how low we can go. There's 10 volts. 9. 6.97 about 7 volts. Still going really nice. 6.2. 5.7. Still going really well. Not putting out a lot through the circuit, but that's okay. Let's see. 4.7. Here, let's jack it up. 13, 14. I really don't want to go too much higher than that. I think the circuit can take it. 17. There's 17 volts in. It's really shining now, brothers. All right. Let's get it back down to a nice 12 volts. So, first run of the big puck, the big pucker. And now, I think before I put any coils here, I think what I want to do is take this puppy apart and rearrange those magnets to get those super poles. See what kind of difference we get. See what kind of difference we get. Oh, I'm gonna have to check the actual speed at 12 volts. I don't think my tack is set up. Let me see if I can do it really quick, but I think I need to have the tape on there. Excuse my wiggling and wobbling. Let me see if the tack no, it needs something. It's black. It's not gonna. Let me see if I can get the magnets. Maybe I can get the magnets. What? 11,000 RPM? That can't be right. Yeah, 14,000 RPM. Oh, wait. Yeah, it's all over the place. 10,000, 9,000, 7,000, 8,000, 9,000. Yeah, I'd have to set up the reflector on either on the cylinder or the puck or on the shaft. All right, guys, so I just wanted to show you the first run. I like this setup. It's pretty sweet. I hope you all appreciate it or like it. Ciao.